Okay, guys, this is your lecture for section 6.1. When you're dealing with writing an augmented matrix, the first columns, okay, are your variables, and the last column are what it equals. These are the variable coefficients here, and this is what it equals. So when I'm writing this augmented matrix, think of it as you're going to have a column for your x's, a column for your y's, a column for your z's, and then a column for what each equation equals. I don't have an x, so 0, 2, -1, 7. 1, 2, 1 equals 17. 2, -3, 2 equals -1. That's how you write your augmented matrix. Now, to solve a system of matrices, you start out by writing the augmented matrix. So 3, 1, I'm going to move that a little further away. 1, 1, 2, 19, and 1, 3, 2, 25. There's two methods you can use. You can do Gaussian Jordan elimination, or you can do back substitution, and then later in this chapter we'll learn Kramer's. I'm just going to show you back substitution right now. When you're writing and solving a system of a matrix, you're trying to write it in what is called row echelon form. Okay, what that means is you want, starting in the upper left-hand corner, you want this diagonal right there to be ones, okay? And you want everything underneath it to be a 0. There's different ways and multiple things you can do. So you start out by doing hang on, my pen just quit on me, so give me just. So you start out by doing what is considered row operations. You can multiply rows by numbers and add them. So to get a 1 in my first spot, I'm going to get rid of my stuff that I circled here. Okay, so I want a 1 that's going to be my first step. I can see that I have a 1 in row 2. So I'm going to switch row 1 and row 2. So now I have 1, 1, 2, 19, and row 1 becomes 231, and then I did nothing to row 3. Okay, so I've got my first 1. Once you get your number that you want a 1, your next step is to make the numbers under it zeros. To do that, you multiply row 1 times the opposite. So I'm going to take -3 okay, -3, I'm going to move this down a little bit, times row 1 and add it to row 2. So I'm not changing row 1. So negative 3 times 1 becomes negative 3 plus 3 is 0. Negative 1 times 1 plus 1 becomes negative 2. Negative 3 times 2 is negative 6. Plus 2 is negative 4. Negative 3 times 19 is negative 57. Plus 31 is a negative 26. And then since row 1 and row 3 have the same thing, I'm just subtracting it. So 1 minus 1, 0. 1 minus 3. 2 minus 2, and 19 minus 25. Now I got the first column completed. So now I'm going to the second column. I don't know why. And now I want to make this number a 1. So I'm going to do got to change my color back just so that I stay consistent. A half of row 2, excuse me, negative a half to make it a positive 1. So going to a new slide here. If I do half of that, I now have 1, 1, 2, 19, 0, 1, 2, 13, and 0, negative 2, 0, negative 6. Now that I have my 1 again, I want to make the numbers under it a 0. So remember, you do the opposite. So 2 times row 2 plus row 3. So 1, 1, 2, 19, 0, 1, 2, 13, 0 times 2 is 0 plus 0 is 0. 2 times 1 is 2 minus 2 is 0. 2 times 2 is 4 plus 0 is 4. 2 times 13 is 26 minus 6 is 20. Okay, so now I'm ready to go to the third column. Okay, so now, again, once I go to the new column, I want a 1 in that diagonal spot. So I'm going to do 1/4 of row 3. Let's move that 1 over closer to the 9. Keep row 1 and 2 the same. So 1/4 of 0, 0, 4. And now I'm ready to back substitute. So if I write my equations for each row, my bottom equation is no x, no y, so I just have z equals 5. My middle equation, no x's, but I have y plus 2z equals 13. plugging my z in, so I have y plus 2 times 5 equals 13. Y plus 10 equals 13. So y equals 3. And then my first equation, x plus y plus 2z equals 19. X plus y is 3, plus 2 and z is 5 equals 19. Multiply. X plus 3 plus 10 equals 19. Combine my 3 and 10 to get 13, and then move my 13 over by subtracting it to get 6. So my final answer is ordered per 6, 3, and 5. That is your lecture for 6.1.